Hi everyone, Mrs. Bridge here. Just wanted to go over a couple of things that we went over yesterday and go over something new that we didn't quite get to. So first thing that we're going to go over is that distributive property. But remember yesterday we added variables into it. So if I'm looking at 7 times t plus 4. All right. Now, remember, don't let those variables intimidate you. And we're still doing the same process that we would do if this variable were, say, 2 or any other number. Okay? We're still taking this outside number and distributing it, aka multiplying it by each term or number on the inside. All right? So the first part of this is going to look like 7 times t, which another way of writing it is 7t. Okay. Moving on, we have to take a look at what operation is happening inside the parentheses, and we must keep that. That doesn't just disappear. So the operation in this case is addition. Okay. And now, since I distributed to the t, I'm going to now distribute the 7, aka multiply to the 4. So I'm looking at 7 times 4. If I were to multiply all of that together, I would get 28. And then I have to keep that addition sign. And we talked a lot yesterday, and you probably heard me say a lot, that we cannot add a number that has a variable attached to it with just a plain old number. They're not the same. They're two separate types of terms. And you can't add apples and oranges together and say you have a certain amount of apples and forget about oranges. Right? So make sure that when you're dealing with variables and numbers, they don't just add together and you're done. Okay? So this would be our final answer to that problem. Let's take a look at another one. Let's say we're given 5 times 4 plus 7c. Okay. If these look familiar to you, then that's great because these were on our Google slide that you got yesterday. So again, not letting that variable intimidate me, even though it's right next to a number in this case, it's not going to be a big deal because I know I just do this distributive property as normal. I'm going to distribute that 5 to the 4 first. So distribute means multiply. 5 times 4 is what I'm looking at for the first part here, which is also 20. And taking a look again in the parentheses, that operation that I have is still addition. So I'm going to keep that there. Now I'm going to distribute that 5 with the 7c. I'm looking at 5 times 7c. Now I know that I can still multiply the numbers together. That's no problem. But I'm just going to have that c attached. So I'm looking at it like 5 times 7c. If I were to put that together, 5 times 7 I know is 35. And then all I'm going to do to make sure that c sticks around is to add it to the back. I'm adding, so I need to keep that there. And again, I'm looking at apples and oranges here. I have no variable here. It's just a number. I have a number with a variable. They have to stay this way, and that is your final answer. Okay. So hopefully that review was a nice refresher. We're going to move on to something new and old. I'll say new and old. All right, we are dealing with factors. I'm still talking about distributive property, but we're going to kind of bring back an old skill. Okay, so factors. Numbers that are blank to get a certain product or answer. Who remembers what this blank would be? Give you a hint, it's one of our operations. You guessed multiplied, you are correct. Okay, so factors are numbers that are multiplied to get to a certain product or an answer. It's just another word for it. Okay, so if I wanted to find the greatest common factor, GCF, of 12 and 16, this is how I'd go about doing it. I'll start with 12, and I need to think of two factors that multiply together to get to 12. I got a couple of options, but I'm going to start with 3 and 4. Now I know that 3 is a prime number, so I can't keep going on and branching more factors here. So I'm going to circle that, and it's just going to be done. But I know I can keep going with 4. 2 times 2 is 4. 2's are prime, so I am done with that as well. So my final factors will look like that. 2 times 2 times 3. Now let's look at 16. Let's see. I'm going to do 8 times 2. 8 and 2. I know, again, prime number right here, so I'm done with that. Can't branch off anymore. But when it comes to 8, I can do 4 times 2. Again, done with 2. I can branch off from 4 and do 2 times 2, and I'm done with that. So that will look like 2 times 2 times 2 times 2. Now, what I need to do is I need to look at the factors that I've listed between these two, and I need to see what they have in common. Now, I'm looking at each one, and I'm seeing definitely things in common. I see some 2's, so let's get back to that in a second. Now, 12 has a 3. But 16 does not. So I know 3 is not involved in finding the greatest common factor here. Now I see 4 2's in 16 and then 2 2's for 12. Now I need to look for the same amount of factors in this case. Okay, so what I mean by that is 12 has 2 2's and 16 has 2 2's. Okay? So when I'm trying to find the greatest common factor here, all I'm going to do is find that common amount in the same numbers, and I'm going to multiply that together. 2 times 2 is 4. So our greatest common factor between 12 and 16 is 4. Okay, so just a refresher there. Hopefully that was a quick reminder of how we do greatest common factor. All right, you're probably wondering, well, why are we going over greatest common factor again? Well, let me bring back my other board here. You are going to be asked to factor out using the distributive property when given expressions that look like this. Okay, so again, we're using it to factor out. Okay, so I'm going to show you what I mean by that. So if I'm looking at 2h and 4, 2h plus 4, I need to find the greatest common factor between 2 and 4. Okay, so I'm going to do that. Good thing with 2, it's just 2, right? That's all I got. 4, though, I'm looking at 2 times 2. Okay? Now, each of these have a 2 in common. They each have 1 2, so our greatest common factor is 2. Okay? Now, what I'm going to do with this greatest common factor is I'm going to set up my distributive property. Okay? So we know our distributive property always has parentheses. And we always have a number on the outside, and since we're dealing with addition, we're going to have that operation in the middle there, in the parentheses. Okay? My greatest common factor, I'm going to put on the outside. Okay? Greatest common factor will always go on the outside. Now I need to work backwards here. I'm working backwards. I need to think back to my original expression, and I need to, if I were to do the distributive property, I need to end up back at 2h plus 4. Okay, so I'm asking myself, well, 2 times what is going to get me 2h? Let's see. 2 times what is going to get me 2h? Well, if I just have 1h here, you can decide to put that 1 there in the front if you want to, but you don't have to. You could just put h2. Okay? Let's just check that really quick. If I were to do 2 times 1h, I would get, well, 2h. That checks out. Now, the second part's going to be a little bit different. I can't just put a 4 here because if I do 2 times 4, I'm going to get 8, and that's not the original expression. So I need to think to myself, 2 times what is going to get me to 4? Well, 2 times 2. Okay, so I've now factored out this expression, okay, and turned it into our distributive property, and let's just double check that we have the original expression that we started with. I'm going to distribute 2 to each term inside the parentheses. 2 times 1h is going to be 2h plus 2 times 2, oh, that's going to be 4. Same as it was originally, and so it's correct. Okay. Let's try one more before this video is over, just so you can see it again. We're going to keep doing this, so don't worry if you're not quite sure about what I'm doing here. We're going to keep practicing this next week. So let's say we're given 3g minus 12. Okay. Again, you're asked to factor out and use the distributive property to kind of rewrite this expression. Okay, so my two numbers are 3 and 12. So I need to find the greatest common factor of 3 and 12. Well, 3 is prime, so that's it. That's my factor that I'm looking at. And I need to do some branching out here with 12. Let's do 4 times 3, prime number there, so it stops. 2 times 2 is 4. They'll stop there. So I'm looking at 2 times 2 times 3 for 12, and then just 3 for 3. So we have to look at what they have in common. I'm seeing no 2's over here, so that's not going to be a part of our answer. I'm seeing 1 3 for 12 and 1 3 for 3. So our greatest common factor is 3. All right, now let's factor this out using the distributive property. So I'm going to set up my parentheses again. This time I'm dealing with subtraction, so I need to make sure I put that operation symbol in the middle. Remember that the greatest common factor is always going to be that outside number, so I'm going to put 3 outside here. And I need to kind of work backwards. What's going to be multiplied with 3 to get back to that 3g? What's going to be multiplied with 3 to get back to that 12? So let's start with the first one. Well, 3 times what is going to give me 3g? Well, it's going to be just g. And the one previous, remember I put the 1 in the front. You could just put the variable. It's going to end up being the same. And now I need to ask myself, 3 times what is going to give me 12? Well, 3 times 4. Now let's check our answer to make sure that we're getting back to our original expression up at the top. I'm going to distribute 3 to each of the terms inside. So my first section, or my first part of the expression, is going to be 3g. I'm going to keep my subtraction symbol. Now I'm going to distribute 3 to 4, so also known as multiply 3 times 4, and I'm going to get 12. And I'm back to my original expression. Okay? This is a way to check your work, but ladies and gentlemen, this is going to be your answer. Again, this is factoring out using the distributive property, finding that greatest common factor.